There's been a lot of time and money in the last several decades spent on shellfish restoration, mostly for shellfish fisheries, food and economic value, but also more recently for restoration of ecosystem services. And one of the components that's often missing in the equation, especially the funding equation, is actually assessing the success of these restoration projects. So Mark Thompson is with us here today. He's from the Sanibel Captiva Conservation Foundation Marine Lab. That's a mouthful. And Mark and his colleagues have been conducting long-term monitoring of community-based oyster reef restoration in Clam Bayou, Southwest Florida. Mark?
Thank you, Greg. We're starting to call it just SCCF Marine Lab. It's too long to say all that. I'm going to talk to you about monitoring of a community-based oyster reef restoration project that we did in Clam Bayou on Sanibel. I want to acknowledge first our partners in this, Loren Coen at FAU and Grizzle at University of New Hampshire. Our funding for this project came from TNC NOAA Restoration Grant. The project site is located on the northwestern end of Sanibel Island in Clam Bayou, which is right up there by Blind Pass, if you guys are familiar with that. The restoration need arose from Clam Bayou is actually part of Blind Pass that got through natural and man-made changes in coastal morphology, got cut off from tidal exchange. And this led to extreme salinity swings. We had mangrove and seagrass and oyster habitat die-offs in Clam Bayou. But in 2007, the city of Sanibel installed a culvert, which reestablished tidal flux there. And this made restoration efforts possible. We have the restoration potential because we still have a remnant oyster reef in Clam Bayou. Even though most of the oysters initially died off, we still have some reef substrate out there, and we actually have some natural reefs being reestablished on their own. But overall, Clam Bayou is a substrate-limited area now for oyster recruitment. And before we began the project, we monitored in Clam Bayou, found that we had pretty fair oyster recruitment out there with the culverts being installed. We also found that red mangroves were not doing very well. There were a few recruits, the propagules getting into Clam Bayou, and they had really suffered from the Clam Bayou being cut off before. The seagrass habitat was poor, but there was a very good abundance of food for oysters. Water quality in Clam Bayou, just to give you an idea, the annual mean chlorophyll A concentration was 11 micrograms per liter over a 3-year period. We monitored it out there, which puts it in the highest 90th percentile of Florida and Estuarine waters for chlorophyll. So there's a lot of food out there for oysters if we can get them established. Mean salinity is 34.5 with a range between about 25 and 38 now. Before they reestablished the tidal exchange, it would be in the mid and sometimes high 40s in there, and so it's come down quite a bit since then. Okay, with this project we established 5 main constructed oyster reefs, shown in the green and red here. But along with the oyster reef construction came propagule planting, red mangrove propagule planting, and we did a little bit of rupia seagrass planting restoration work. We established the oyster reefs through a lot of labor. We had a lot of volunteers, over 500 volunteers. I think we had like 1,200 or so man-hours labor, placing 6,000 bags that weighed about 30 pounds each of oyster shell on the reef areas. Basically, we took them out there on a pontoon-like barge and placed them by hand to form fringing reefs in areas that we had good recruitment, but there wasn't really much shell at all there at the present time. We started the project in April 2010, and we finished, pretty much were completed by August 2010. And this is what a typical fringing reef looked like after we got it done in 2010. In each of the reefs, we installed 15 what we call monitoring trays. Basically, they're Coke container carton made out of plastic. They have fine mesh in the bottom and then coarser mesh on top. They hold the same amount of fossil oyster shell as one of those bags did, so about 30 pounds worth of shell. And we would leave these monitoring trays out of the reef until we thought they had enough time period to collect spat. We were looking for recruitment and looking for being able to measure oyster density. So basically, we would take after we monitored every year. So after a year, we would come out to the reef. Each reef we would randomly pick 3 of the monitoring trays, take them back to the lab, and then we would run all the oyster shell inside there through a sieve to be able to collect the resident invertebrates that were in that monitoring tray, as well as collect the oysters and then the fossil oyster shell, and then count the oysters attached. Like I said, we used a sieve to collect the resident invertebrates that would be in there. And these monitoring trays were located about mid-elevation on the reefs. There's a picture of one in the reef. In addition to the constructed reefs, we placed these monitoring trays in what we call natural reefs in the area. A lot of times they would just be more shelly areas that had recruitment and actually had oysters growing on them. But we placed those monitoring trays in those areas too, so we could compare our constructed reef to more natural reefs in the area. Before we actually constructed the reefs, we wanted to have performance measures that we could determine if our choice of reef sites were good, see if we're doing a pretty good job of constructing reefs out there. From the oyster restoration work group, we chose performance measures that we could look at later, after a year or so, to see if our reefs were meeting our hopes. Some of our performance measures were reef area. First of all, it was constructing a reef area of at least 400 square meters. We wanted to get that much out there with the amount of funding we had. We were hoping that we would find an oyster density of at least 100 oysters per square meter, and that our species richness of resident inverts would be at least 10 or greater. And for water quality, we were hoping that we would be able to measure some kind of improvement in water quality, and we chose a measurable reduction in chlorophyll A over the reefs as that performance measure. By the time we got the project completed in August 2010. We had constructed 850 square meters of reef. And these were the 5 main reefs that we constructed. And after we looked at the trays, we pulled the trays in April 2011, 8 months after construction. And then we pulled them again in August 2011. And then we sampled every August the next 2 years. So we had a little bit of insight into intra-season variability in oyster density. You can see that in April 2011, our mean oyster density was, just under 700 oysters per square meter. We thought we were doing great. But then when we went back out there in August, our mean oyster density had really dropped on our constructed reefs. And this, we think, correlated with the presence of Perkinsus in the area. And even though the oyster density dropped, because we had already established, a good oyster density out there, where we are constructing habitat, we are constructing structure out there that provides habitat for other critters. So after 2 years, our density went up on our constructed reefs, but it went down on the natural reefs. And pretty much the last 2 years, our constructed and natural reefs our oyster densities have been pretty close. But initially, the natural reefs were much higher oyster density than the constructed reefs. Our resin inverts, there wasn't really any significant difference between the natural and constructed reefs on resin inverts. Mostly, we had xanthan crabs, some like McKenzie mussels, and some polychaetes. But we averaged a little over 10 species for the constructed reefs over the monitoring period. For monitoring water quality improvement, we set up in-situ fluorometers upstream and downstream of the constructed reefs. There's a fluorometer upstream and downstream of this reef. We would record the data. The top graph shows, I guess it was an outgoing tide, and then the blue is the upstream concentration of chlorophyll A, and the red is the downstream concentration. You can see that there was a significant clearance of chlorophyll A over the reef. And what's interesting is we left these fluorometers out there over a tide change, and we were able to see that the downstream and the upstream switched just like we would hope to have expected. And we averaged about 20% reduction in chlorophyll A concentration over the monitoring period of the reefs that we monitored. And the individual clearance rate for chlorophyll matched up pretty well with literature values. So we felt like what we were finding was significant, and it was real. So after 3 years, a quick summary of our project. We had a target of 400 square meters of reef that we wanted to construct. We managed to get over 800 square meters of reef out there. We're hoping for at least 100 square meter, oysters per square meter oyster density, and we range between 220 and 690 during the monitoring period, averaged over the reefs. We're hoping to have at least 10 resident invertebrate species, and we averaged just over 10. And we found that we had a significant reduction in chlorophyll A over the reefs. So we were pretty happy with the results, and the reefs are still producing habitat and structure out there, and we hope to be able to keep monitoring these reefs for the years to come. Any questions?
Mark, one thing I noticed that you did not measure, which was pretty easy to do, and it might explain some of the densities of your oysters, is oyster size. It might give you an idea, about size class distribution, settlement, and possibly year classes as well, since this is a multi-year thing. Any thoughts to that?
Yeah, we actually have that data, and we reported it, and I just didn't include it in here. I just tried to make it simpler.
Okay.
Sorry.
Pretty important piece of information, especially if you're going to look at clearance rates, and actually sometimes standardized clearance rate based on the size of the animals as well. That would be useful to some of us who are interested in this. Thanks.
Great. I'll include it next time.
Thanks, Jen. Any other questions? All right, thank you, Mark, and thank you all of our presenters.